Ora viva! Bom dia! Hi guys! Just finishing up. We will start soon, okay? Can you guys listen, hear the that? There's someone here using a pneumatic hammer. Let me just drop this down further. It's perfect? Nice. Just my voice? Great, poker face. Okay, cool. Cool. So, uh, I'm doing this remotely today because another professor was uh, was in need of doing his own lecture remotely, and because for some students it will be impossible to attend both of them uh, in person and remotely. I figured out this would be the best solution, but this is a one-time event. I will continue to lecture on the usual room, okay? So don't worry. No, you don't hear anything, but I am listening to it, but well, I'm hearing it, but it's okay. Well, I will try to get around it. So about today, we will start slowly. There are only yet 30 people watching, but the video will be on YouTube. I am usually expecting more. Let me see whether, okay, it's going out already to YouTube, so it's okay. I will start by showing you guys some of the changes I've made to the demo. My purpose today is to look at the view model, okay, and its role in the overall application architecture. I've started to introduce the view model as the host of the UI state machine. Okay, so I've described for each screen I will have a view model, and that view model is the host of the screen state machine. And I will show you what that means exactly by using the source code of the application, of the demo application I am building during the classes. Okay, so let's get to it. Let's get to it. Today I will be more watchful of the bom dia, Nico Gato. I will be more attentive to the chat, okay? Because I don't have eyes in front of me or on my left as usual, but so I will try to be very aware of what's happening on the chat. So if you have any questions, you know already the drill. Put them there, and I will do my best to answer them, okay? So, but for now, let's start by looking at the code I was talking to you about. Here it is. Okay, so I will. Obrigado, John. Lurk in the shadows. Okay, so I was saying the first purpose of the view model is to behave as the host for the screen state machine. I remind you that there are parts of this which are subjective in nature and others which are objective, and therefore they must be done that way. Okay, I will try to along the way clarify which of those we are talking about. For example, the idea of building screens as state machines is subjective in nature, meaning that it's not the only possible approach, okay? But I think that it works well, at least in my experience, okay? Let me just see, okay, cool. So, but regardless of working well for me, according to my own experience, it is subjective in nature, okay? So this is the first observation. Regardless, I went through with it, and I said, okay, cool. I have a crowd that let me, you can see this, right? The code. Maybe I should make it a little bit larger, like so. This is too much. You guys can see it, right? Like this. my video quality isn't that great, so I'm not sure. I'm following the okay. I think so. I was saying that yes, the class will be on the on YouTube. It is there already. Okay, it's going live to YouTube also. Okay, and it will be on the usual playlist. Okay, Sam. But continuing, let's continue. So I was saying that the view model is therefore, for in my case, the host of this for the screen's state machine. What does this mean? Well, let me show you guys. I will increase this for a bit. What does that mean? That means this. Okay. Let me run it so you guys can remember what we were doing previously. Okay, here it is. So the crowd tally demo, I have another one there. This is designed as a state machine, and now, okay, we have this behavior. If we are in the state of configuring it, it's behaving accordingly on reconfiguration. And if we do this, let me just save it with 10, save, and now I can go no further than 10, and if we lose it. Okay, this was by design. We will address this further on. Okay, but regardless of keeping the count, of not keeping the count, it keeps the state, the current state. Okay, as we have observed. But this is for now by design, and therefore this is what we have. Let's see how we are implementing this. Okay. We have the crowd tally activity, which has associated its own view model, which is the crowd tally view model. Okay. In order to navigate to this activity, I have placed this navigate in a companion object of the activity. This is the way to ensure that we do not repeat on every possible source the intent instantiation, its preparation to be sent, and in the actual navigation itself. Okay, start activity. This is a possible approach to. Several of you guys have reached out and asked me, how can I prevent that repetition? Well, this is a way to do it. Okay. Again, the view model. What is the view model? Well, let's look at it. We have seen that a view model is the host of the state machine, in my case, of course, and there are two states in the screen's state machine. The configuration state, which has a capacity, and the counting state, which has a crowd counter. And then the view model hosts the current state of that state machine, okay? And the current state is counting. We are using, for now, a mutable state of. Several of you guys have asked me about this by. Okay, so I will try to clarify what is this by here, okay, doing. Thanks for the sub, globular. And I was saying, I will try to clarify what this by is. Again, I understand that when you have a huge classroom filled with people, we have some questions and we don't feel comfortable in issuing them out loud, but remember, a classroom in my mind is a safe place. So we are learning, of course, and therefore if we are learning, there are stuff we don't understand at first, and there are stuff we don't know, and this also applies to me. Okay, I don't know everything, of course. So ignorance is a transitive state. Okay, it's not a permanent state. We are ignorant and then we learn and then we are no longer ignorant. So it's okay. Okay, guys. So looking at this first and foremost, prior to that, look, we have the state transitions here. Configuring. Okay, cool. Configure is about what? checking whether we are on the counting state. If we are already on the configuring state, there's no point in changing anything. We are there already. And therefore, if we are on the counting state, then it makes sense to transition to the new state, configuring. Cancel configuration is about leaving the configuration state. Therefore, if we are on the configuration state, we will do something about it, which is leaving that state and going to the counting state, okay? And also in the save configuration. Here it is, the state machine. A simple one, but regardless, it's there to illustrate my point, okay? So again, who calls this configure, cancel configuration, save configuration? Well, the screen, of course. And here it is. Let me close this. This is another demo I will show you today, guys. Show you guys today. Main screen tests. I have tests, automated tests for all of this. User task screen, not that, not that. Main activity, not that. Okay, let's look at the screen itself. Okay, and the screen handles those configuration changes. Those state machine transitions. Like so. When we are in the counting state, we display the counting view, and the counting view, okay, for now just doesn't produce any events. This is why we don't have a preservation of state, namely the current count. Okay, it was for now a design decision. We will get into it later on. And also we have, if we are in the configuration state, we display the configuration view. And here, yes, we do have the handling of the state transitions from configuration to counting, like so. If the user said save it, we say view model, save the new configuration. If the user said cancel it, we say view model, please cancel configuration. This leads to the state transition, which in turn leads to the recomposition of the UI and displaying the new UI that results from that state transition. Okay? This is why we need a mutable state of. For now, we are using a mutable state of, which is the way of incompose, the first way of incompose, being attentive to state changes, okay, and producing recompositions as a consequence of that state changing. Okay, we will later on change this to another more general approach with flows, but for now we are using mutable state. And if we look at mutable state of, this produces a mutable state instance here. Okay, mutable state is let me just click here and check it out here. And if we look at it, we observe that mutable state is a value holder, right? Cool. That inherits from state. Okay, so it's a value holder. Oh, a value holder. Then, for sure, we could do something like this. Now I'm trying to explain the by there. Okay, we could do something like this. As you can see, we have the compiler is warning me. Look, what are you doing, man? Are you insane? And I will state that this is a mutable state of crowd tally screen, like so. Still, the compiler is wild. Look, what are you doing, Paulo? This is because state dot value, state current state dot value. Okay, we have an indirection. It's a state holder, not the value itself. Okay, and we need also to do this like so, dot value. So it's simple, right? I mean, instead of having the state, we do have a state holder. The state directly, we do have a state holder. Why do we need that state holder? Well, to intercept all mutations, so that triggers a recomposition. Okay, so that's the reason for it. Instead of having to write dot value everywhere, it would be nice to use directly the content, the held value. Okay, this is why we use By is delegation, meaning that it's expected to have an indirection. It's expected to delegate all the operations done into that delegate forwarded to the value, to the delegated value, okay? And this is why now, instead of having current state of type mutable state, because we are using delegation, it's actually of type crowd screen state, the held value, okay? Because this delegates automatically to the dot value. It does the dot value for us, simply stated, okay? And there you have it. I hope this has made it clear why we are using by. To make sure that we can use delegation here, we have to do this import, these import. Oops, sorry about that. Get value and set value, okay? If we look at it, you see the delegation here, okay? The value is set onto the property which is held by the mutable state. In this case, it's mutable long state, but you get the idea. There are several variations of mutable state holders according to the several held types, okay? And that's it regarding the by in this case, this by in the view model. But we were using another one, okay? Another by, another delegation. Like so. So the crowd tally, okay, crowd tally activity has associated to it its own view model, okay? And I was telling you about the relationship between the activity. We will revisit that in this class. I told you last lecture that the activity is a view model store owner, meaning that it can store view models, and that the way to get a view model is not directly instantiating it, calling the constructor, okay? No, it's not that. Why is that? Because that would defeat the purpose. The way is to use a factory function that verifies whether the instance already exists or not. If the instance does not exist, it creates it. If it already exists, it produces it. It returns the same instance, okay? I will exemplify with the demo I have built here later on. But for now, I'm using the view models factory function, which returns the view model for this activity. If it's the first time we are calling this, then it produces a new instance of the view model. What is the result of a view model of this function? It's a lazy. So, meaning this is actually of type lazy, lazy of crowd tally view model, right? Like so. Meaning that if we want, again, what is a lazy? Look, it's again, an instance holder. Oh. Meaning that I can also use delegation here, okay? And if you look at it, if I have to refer to the actual view model, I would have here the value, okay? Again, but this is cumbersome. It's not cool. It's not cool, right? It's too many letters. Why I need to do it if I can do it automatically like this, like by using delegation. When I'm using delegation, exactly the same approach as before, the type of the property is no longer lazy of, but of the held value, crowd tally view model, and therefore we can use it here, okay? In this case, the reason we are using a state holder is different from this one, ok? Grande abraço, Márcio. Tudo bom? Obrigadinho. I was saying that in this case, the reason we are using a state holder is different. In this case, or for the view model, we were using a state holder. For what purpose? To make sure we could intercept every mutation so that we can trigger a recomposition in compose, right? Here, the reason is another one. There's another reason for this indirection, for this state order. It's that it's about the activity life cycle. That is the problem here. Remember, the activity, there are two moments here. The moment where our activity is created, the instance is created and initiated, and this is the moment where this code executes, and then the moment where that is signaled on the activity life cycle, meaning the activity is, its on create is called signaling that, okay, the activity is prepared, it's initiated. Meaning, this means, what does this mean is that we, at this point and at this moment in time, we cannot access the activity properties. Why is that? Well, because the activity is not yet initiated. Some of its properties are not stable yet. So here we need to defer the access to the activity properties. Okay, this is important. It's not a choice, it's a requirement. We need to delay the actual access to the view model, and therefore the lazy is used here. The by here is required, and it's required, of course, to have to ensure we do have a lazy. Okay, a deferred initiation of the view model. Okay, like this. I hope this makes it clear. Okay, so we will continue. If you guys have any need further clarification, please just tell me. Okay, I think this would become clearer later on when we will start to have parameters on this view model. For now, we do not have them. Okay, but let's proceed. I have prepared a demo like this demo. Let me just show you. This is the crowd tally. We will get to it later on. Now I want to show you the user task demo, so we can understand better how does navigation work and how does the relationship between activities and its view models is implemented. Okay, so let's user task demo. Okay, what do we have here? Let me just hide for a moment my camera. Okay, so you guys can see what I mean. Okay, cool. So I was saying, what we have here is a small demo that uses several ways of launching activities. Okay, the one I already shown you guys, the standard way. Okay, like this. For example, this is a activity which has been launched through a standard approach. Its on create was called. If I launched an B standard also, this happens. Here I am displaying the trace of start activities. Okay, I am tracing all the start activities and I am displaying that trace here. Okay, again, you see at the top we have at the top of the user task we have a new instance, in this case of B, activity B. I will continue with A. We have a new instance, which is A. Okay, so we see there's an instance of A, an instance of B, and an instance of A. This is the standard approach to navigation using start activity. If I go back, we see this. Okay, again, user task demo, B, A, B. I could go on. Okay, we see there are several instances of A and several instances of B. Okay, cool. If I go back, all of them are there. Other way of doing it is this. Instead of using, oh, by the way, I can do this, A, and A, and A, and also A. You see, there are several instances of the same activity type, okay? Each of these instances has its own state, okay? Cool. Again, if I go back, and now to the previous screen of launching the several demos, okay? This is using start activity with the default launch mode, okay? But we can control how activities are launched using two possible approaches. Using activation flags, okay? When I create the intent, a flag, I use flags to state what I want to do, okay, when activating that activity. I will show you guys an example. For example, this. I'm saying that, cool, I have A, let me start B, and now I want again A, but I want to make sure that B, everything that it's on top of A, let me add many B's, everything that is on top of B is cleared. That means, on top of A, I'm sorry, is cleared. I want to go to A and make sure that all activities that are on top of A are cleared. So what happens is this. This is the trace of calls, not the user task itself. I will go back now. You see, the same instance is here, A, 590. Single top, clear top, reused via on new intent. We will see what this means later. Now I will go back and we will see the launching screen, like so. Okay, so this is how we can approach the details of navigation you will have on your application by using activation flags on the activities. Okay, there are several possibilities. This is just an example. Okay, but my point here is that it's possible for us to control how activation occurs. Okay, meaning we can reuse an already existing instance, forcing, okay, all other activities that are piled up on top of it to be dropped. Okay, so that one reappears like that, like I have shown you here. Okay, again, standard. Oh, clear top, drop all B's, and bring the A for the top again, and that means that I go back and there are no B's here. Okay, I hope this clarifies how we can manipulate navigation in our case. Maybe I could do a little better here by stating of which type is the current activity, but I think it's easy to see that at the top is always the current activity, so the type of the current activity is A. How have I built this? What have I done to enable this demo? Let me show you guys. It's not a big deal. It's not rocket science. It's simple enough, I think. We do have here a user task demo activity. That activity is also, you can look at the log, is also logging all the calls to these callbacks on create. On create means, look, you've been instantiated and your constructor has already executed. Please finish up on your initiation. Okay, you have been created. This is what this means. This means on new intent means, hey, you have a new intent. Okay, do something about it if you want. Meaning that instance has been reused for some reason. Okay, like I've just shown you. For example, if I use clear top. Okay, and this on start means what? Look, you're visible. Do something about it. In this case, I'm only logging. And this means, look, you are no longer visible. Care to do something about it? And also this means you will be destroyed, okay? Something menacing like that. You are dead. Okay? I hope it. Finally, I have here on create and on new intent um, two calls to handle incoming intent, meaning that I can receive an intent for the first time through on create or multiple times on new intent, and therefore I've captured that content and put it here on the handle incoming intent. And here it is. On handle incoming intent, what does it do? Well, simple. It gets the current trace and adds a new node, the node for this activation, okay? And therefore I look at my intent flags, whether it has been reused or not, okay? And look, reused for on new intent, false for on create. And finally, I add that new node to the trace, and I pass on the trace to user task screen, which displays that, okay? Navigation, how is it done? Well, on back intent by finishing it, finish the activity, on start A or on start B by doing handle navigation with the current trace, the flags I wish, and which is the target. Finally, handle navigation does that, instantiates the intent, applies the flags, and passes on the trace. Passing on the trace is about putting on the intent as an extra the information I require. In this case, it's the list of trace nodes. Forgive me. Okay? There's one requirement for the data I've put on as an extra. And that requirement is the representation must be an external representation, meaning that it must have a meaning outside of the process, okay? In this case, I'm making sure that this is true by adding a capability to this data, which is to have an external representation in the form of a parse label, okay? I will show you guys in a minute. So this is not a regular trace, is a list of trace nodes, and trace node is where is the trace node? Let me go to it. Trace node, here it is. Trace node is a data class with a string, an integer, and a string, which is a launch node. Then I'm saying it's parse label, meaning that there are external representations of it in the form of parse label instances. How do I build a parse label instance? Well, in this case, I have done it automatically by using the parcelize annotation. The parcelize annotation produces extends the compiler behavior by adding the code required to build the parse label code, meaning, as it says there, how write to parcel is done and how an instance is created from an instance of trace node is created from a generic parse label, okay? I can show you guys later on details on how we do it by hand, but I think that it's not particularly interesting doing it by hand. I've done it many times. I think it's more pleasant to have that built automatically using this annotation. By the way, this annotation I've said that this is done through a compiler extension. How am I including that compiler extension? Is like this. No, not here. Here. Okay, you see here, guys? I'm saying that there's another plugin, and that plugin is Kotlin Parcelize. And that plugin will make sure that the required code for creating external representations is added to my data type. Okay? As simple as that. But it's a requirement. Data that crosses activities as extras must have external representations or be an already supported type, okay? Meaning that those types are already supported because the system already knows how to create external representations of them, okay? If we are defining our own type, then we need to state that how that type creates or how external representations of that type are created, okay? And this is done automatically in this case, using the default behavior, of course. More. What do I have to show you more? So I am passing on the trace as an extra, meaning that this is a way to pass information between screens, between activities, but bear in mind that this has a limitation. We cannot, there are limits to the amount of information we can pass on using this approach, okay? So be wary of that. In this case, we are simply passing a small list of trace nodes, so not a big deal. But we cannot pass, obviously, all the contents of the data of a local database here. Okay. So it doesn't make sense to pass that kind of volume of information. So cool. We already have the demo. We already seen. Another point. Just to prevent repetition of all of this, I have used the user task demo activity as a base class for both the A activity and the B activity. Okay, that's it. And at the beginning, we start always at A. This is what this means here. Okay, and that's it. Cool. Finally, we also have to understand the relationship between the activity, and this is the preview of the screen. So not a big deal. And for launching each of these buttons have different flags. For example, activity clear top or single top. In this case, reorder to front, bringing the activity to again to the top of the I can show you how this works. Reorder to front. Let's look at it. But yeah, you can explore this. I will put in the summary a link to the possibilities, and like that you can control all of your needs for navigation in your application can be addressed, okay, with this approach. Let me just show you again user task demo. I was speaking of reorder to front, right? Okay, I can put again the camera. Let me show you again the reorder to front. Close this. Again, B, and let's reorder to front A. So we have, remember, 1A and 2 Bs. I will pull up A. Let's reorder to front A. You see? But in this case, the 2 Bs have not left the user task, the backstack. Look, we go back, we go back, we go back, and now we are at the root. Okay, so experiment with this demo. Try to use it. My intent here is to help you understand how this works. You can fool around with it and figure out how this works. So I think this will be helpful. Another point I want to make is to underline the relationship between the activity and the view model. So let's do that now. User task demo again. Now we have an instance of A and the view model for that instance. Let's see here whether we can check it. Whoa, okay. So this is my package. Do I have logging with what? User demo. So user task demo, here it is. We do have here, let me clear the log. Let me clear the log so I can clear logcat. Yeah. And let me run it again. I want to, this is different. Let me see, show toolbar, close all. Okay, locket again. Okay, here it is. So I was saying that clear locket, user task demo, and nothing is shown there. Okay, cool. Now we do have an on-created, an on-start on activity of type A with hash code instance 185. Now, if we start another A, we will see we have another on create, another on start. I used create A, another A with standard launch mode. Okay, another on create, and then we have here another instance. Now we have an on start stating, hey, look, instance 529, you are visible, and an on stop here saying, hey, 185 instance, you are hidden, you are not visible. Okay, okay, cool. So I was saying that if we have this, we have actually two instances. There they are, two instances of the same activity type. Cool. So how many view models do we have? Let's see it. Let's head logging to the view model instantiation like this. Like this. Oh, we do not have a view model, right? Let's head it. Cool. Let's have a view model to here. So we want a view model. Okay. View model val vm by view model, like so, view models like this, view models like this of type, we will say user test demo activity, right? Nonsense. Let me add new Kotlin class file. This is user task demo view model. This inherits from, well, you guessed it, view model. And it has a, let me make this a little larger. And then we have here an init where we put the log message, like so. This is the log message I want to, or not, an adaptation of it, like so. I will use on the log user task demo on create no init, cool, and it's hash code. Great. Let's now do it here. I don't want this, I want this, like so. Cool. And now we must access it to make sure, because that is lazy. Remember, that is deferred. I will have some function do something, or otherwise, if I do not access it, something, it will not be instantiated. Okay, remember that. I can do log v. Okay, log v doing something. Do something. Oops. In hash code. Okay, cool. Let's do that. Now we have user task demo activity. Here I use do something on the view model vm dot do something. Cool. And now we go and run it and see the behavior. Here we go. So Let me see whether we can make it this smaller. Compact view. Cool. So here it is. We do have here on create, on start, in this instance, we also do have, okay? So this is model, view model init. You see here, do something. Oh, by the way, the do something appears prior to on create because it's the order of those log messages. It's not intuitive, so I will change it so we don't get confused, okay? And let's go again. And here it is again. Okay? On create, init on the view model, do something on the same instance of view model, on start on the same instance of activity. Let's do again a start, a standard. So you see here it is. A new init, okay, with a different hash code, therefore a different instance. So this means that for the same type of activity, for each instance of that activity, there's its corresponding view model. So the view model is not shared between all instances of the same activity. This is a huge tell, right? Because this leads to the idea that, okay, so then the view model is in some ways a part of its activity. And yeah, it's the part of the activity that survives reconfigurations. And because it survives reconfigurations, it's the ideal proxy for interacting with the remaining of our system. Okay? And that is the view model role, I remind you. Okay? So the view model is about proxying all operations between the UI and the remaining of our system. Okay? Cool? This means that the view model, I hope this is clear, okay? If we use a reorder or clear top, or we try to reuse, of course, this do something will not occur. Why is that? Because we are not calling it. But if we do call it inside handle incoming intent, we will see that the instance is preserved, okay? So the relationship is maintained. Meaning, for some activity, activity of type A, there's an instance of its view model for each instance of that activity type that is on the user task. Okay? So meaning here we do have two instances on the user task, and therefore we have two instances of the view model. If we reuse one instance, its view model is reused with it. This means that the view model and the activity are two parts of the same whole, of the same, okay, which is what we use to implement screens. Okay, cool. But I was saying, if the view model is the proxy for the remaining of our system, then the view model needs to receive parameters. We need to inject dependencies on that view model. How do we go about it? How do we do it? Let's do that now. For that purpose, I'm using a small demo, which is I will be doing later on, which is a demo for displaying jokes. So my purpose here is a simplistic approach to making HTTP requests to some existing web API. And I will name this demo joke of the day. So the user will launch the demo and witness see the joke of the day. That joke is provided by some remote web API. Okay. For now, we will start by using fakes, meaning that we can control all the behavior without the need to actually having a web API. And we can perform all the development this way until finally we do actually have the web API. Okay, so this is an hint. It's some hint to you guys in your development process for the courses project. So I was saying, let's go and address um, that that demo. Here I do have something I already talked to you guys about, which is the joke of day service. Service to get the joke of day. An abstraction, an abstraction, an abstraction that to be implemented by different approaches using different data sources. Okay, I will show you, for example, there are two, at least two web APIs I'm aware of that they have jokes. One is jokes of using using dead jokes, so those types of jokes which usually our sons don't have don't find funny, so dead jokes. And another one is Chuck Norris jokes. Okay, um, well, just for fun. Okay, so here it is, and you guys remember what I've said about this? Okay, I like the comment here about this. If our intent is to get the joke of the day, and if this implies I/O, then we must have a suspending function, meaning that in Android's concurrency model, it is forbidden to block the main thread, the only thread we have thus far, the one that handles callbacks and handle events, user interface events. It is forbidden to have that thread blocked. Okay, so this means that we cannot have I/O blocking I/O, at least not on that thread. Okay, and therefore maybe then we should use instead suspending functions. But to use, and there it is, but to use suspending functions, we need to be able to create coroutines. We will get on that to that later on, but for now, I'm only stating that, look guys, this needs to be a suspend function, okay? I will, for the sake of simplification for now, take it out, okay, and go with it like this. Okay, a joke with its content and source. Cool. This is the service. A fake implementation of this can be, of course, class fake joke of the service. I like it. Why don't scientists trust atoms? Because they make up everything. Okay, it's a dead joke. My God, best science jokes. Okay. GPT has a sense of humor. No, Copilot sense of humor is not that high. Maybe we should use instead something like this: Chuck Norris jokes. Chuck Norris jokes API. Chuck Norris jokes API. Here it is. I prefer it this way. Chuck Norris jokes API. We will use something like this, okay? So let's get it. Usage. Can I run it like this? Nah, let's do subscribe for new Chuck Norris fact is a free JSON API for end curated Chuck Norris facts. Get Chuck Norris hook. Okay, this Chuck Norris is the fifth Beatle. Get me a new one. The quickest way to a man's heart is with Chuck Norris's fist. Okay, this is better, I think, but it's disputable. So let's go. You see, the general idea is to make an HTTP request and get back a joke. Okay. For um, for now, we will use this with a fake implementation, of course, like this. Okay, a bit violent, but yeah, it's the fastest way. Copy link. Okay, and here it is, the source. Okay, Chuck Norris jokes like this, and this will return always the same joke. Okay, cool. I can make it also, instead of already returning the joke, to make it take a bit longer. For example, simulating delay on the network, like so, 2 or more if I want to, 5 or 10, to make it actually obvious. Okay, so this is a good way, an ideal way to address the need to have interaction with other nodes, in the case with external systems. Okay, by having a fake implementation of it in order to be able to simulate several circumstances without the need to intervene on the foreign service. Okay, but let's do like this for now. And now we do have a joke of this service, a fake implementation, an abstraction, a fake implementation of it. And how do we get it? Okay, one way. And how do we pass it on? Oh, this is wrong. Let me just refactor, rename it demo view model. Cool. I hope this refactor went well. And now I was saying that I need to pass it on here, right? I have to send it in to the view model, not this one, of course. Let me just build the activity and its view model in Rush, like this. So we do have the joke, we do have the new Kotlin class file joke of the activity. It derives from it will be on the domain on the joke. I will move file to cool. Let's do that. Now this is an activity, meaning it derives from component activity. This one, cool. They're the same, but yeah. Now I do have a view model. This is how it's done. Navigate to it. Cool. The AI is already learning how am I doing this. So it's proposing the same approach that I had on other demos. I like that. Now I will override on create. There are two or many. Actually, I remember 2 by heart, but maybe there are several others. But I will use this version of on create. Now I do have to do a set content of a joke of the screen. Cool with this. Cool. I also like it. Let's do that. Import extension function joke of the screen. Let's create it. Interface. No, none of this. It's a joke of the screen. It's a composable function. Let's add it here also. New. So I'm doing this almost brainlessly, meaning that it's a convention. For each screen, I have an activity, it's root composable, and its view model. So there's no need to think through this. It's the pattern I'm using, okay? And this is a good thing, okay? We need to make sure our software keeps simple enough. It's kept simple enough. So again, the joke of the screen, let me add it here, new Kotlin class file. It's a file joke of the screen. The screen state is hoisted up. Navigation navigation. What happened? Navigation is handled. Composable function. Composable. Here it is. Fun. Joke of the screen. It's a composable function which has an on-back intent. This is not what I'm doing here. Okay, let me leave it out to later to do. Now I do actually have an on-back intent. For example, through a top application bar, and then a back button. It's okay. Now I have a joke of the screen with on-back intent. This is good. I don't want to do this. Nothing like this. I want to do finish. He is learning, but not yet fully, has already fully learned what I want. And finally, I need to address how to instantiate the view model. So here it is: private val view model. We do have a by. View model name is not created yet. Let's add it here now. So it's a joke of the view model. Joke of the well, refactor, fat fingers, refactor rename, joke of the screen view model. Remember, it's not a view model per application, it's a view model per screen. And this derives from view model, activity life cycle, and here we will have what we need. Okay. The AI is trying to do stuff for me, and it's not helping, sometimes not helping. Okay, cool. Finally, I need to instantiate it. Joke of the screen view model, joke of the screen, and joke of the activity. There it is. VM by view model, VM by view model. And this is imported extension function. There you go. Okay. But now this instantiates this view model with no parameters. I wish to pass on parameters. Why is that? Because if in the view model I would use the fake version, if here I would use private, well, joke service, something like this, joke of the service, fake, the fake one, fake version, fake joke of a service. If I would do something like this, this would mean that I am compromising the view model with a fake implementation. How can we test this? Right? More importantly, how do we change it? So to enable testing, we should pass on to the view model through a construction parameter the service, right? Joke service, which is of type the abstraction, not the factual service. It's a joke of the service, like this. We can, of course, make it like this. If nothing is passed on, we use a fake implementation, but we actually don't need it because we will always pass it in. Okay? And we will deal with it, use it here later. Okay? So how do we go about sending in a dependency to the view model? How we do it? How will we do it? Okay, let me just view model for the joke of the day screen. And it holds, I don't want to say this, I just want to say that this is a property. There's a property named the service to get the joke of the day, it's okay to get the joke of the day. Okay? And here we go. So, again, how do we go about it? Cool, no problem. Here, we will say on the activity, instead of using the default construction, we must use another approach. In particular, we should use this factory. The view is already guessing. Joke of day screen view model factory. Okay, cool. How about we using this approach recommended here? Let me fetch the documentation. Where is it? Where is it, Paulo? Documentation. Okay, here it is. Create view models. Let me, like this. Instead of using some random approach, why don't we use what the documentation proposes? Hey guys, what about using a companion object with a factory property which implements a view model provider factory, which is the contract needed to provide it to the activity, or provide it in the activity to the view models factory function. Okay, let's do that. Okay, let's build it. So I'm saying, cool. So we have, oh, so I'm saying is, cool. So we have here a factory. Great. Let's take this out. Let's close this. So we don't have enough space on our screen. So we will remove this. I'm not okay. So now let me look at the chat. Okay, cool. And I was saying I will receive in the view model. This is not required. I will receive in the view model the joke service. Here you go. And now we do have a joke of the activity that instead uses the factory. So this is a companion object. Cool. We do have a factory, oops, which is of type view model factory, like so. Whoa, what is it doing? So it's of type view model provider factory. Okay. Import. Yeah, I want to import it. And now this is of type view model provider factory. And now we initiate it with, yeah, a singleton instance, why not? Which implements the factory, the create, which returns a view model by receiving the model class like this. Okay, I like it. Here we are giving him a fake. There's, let me just clean this up, is assignable from this a verification to the unchecked class. Cool. I do have here some issues here, right? I don't like this. Why is that? Because we have changed we have changed it from a simplified compromised like this, private dependency like this, val joke of the service equals fake joke of the service, right? The dependency is expressed here, right? We have changed it to a more elaborate one. So I don't like it, really. It's not great, right? You understand the problem? So we had this, and now, as suggested by the documentation, we do have not the documentation itself. Okay, it's something else. I will show you later on. But as using this approach and using the AI suggestion, we put this here, right? But this is the same as this. So how should we go about this? How should we ensure that instead of having this hard-coded dependency, we actually have something better, meaning that we can change it from the outside. Okay, cool. So here, the companion object, instead of using, this is the factory provider, instead of using this, must resolve differently. Okay, let me just do this. Val the service implementation to do. Okay, and here, which is of type joke of the service, which is of type the service implementation, which is the service implementation here. Okay, so we do have here the same problem. How do we resolve the dependency, right? So this means that I'm not very fond of this approach suggested here. Okay, I think you already guessed it. I'm actually not very fond of this. Okay, because apparently we are putting on the same place the dependency, unless we look into what is being actually done there and realize that here, you see here, application as my application. So the view model is passed in what's there, what's in there. Application as, what is that actually? Okay, so what is that? Okay, see, you see my point? So what is that? What is application dot something? Okay, cool. So if we go here, application. What is the application? What is this? The documentation is talking about. Let me show you once again. So here you go. Application. Here. What is this? Okay. View model, factory, application. Where does this come from? Okay. Model class, access, creation, access. Where does this come from? View model provider, factory. Where does this come from? Application. Well, let's look into it. Okay. First and foremost, maybe I can first and foremost, I'm not sure if I can finish up, but the idea is that we can actually look at each component in Android, each component as associated to it an application instance, meaning the application context. Okay, we can actually control the type of instances that are created for that application context. For example, if I look here in the activity, I actually do have an application, you see, which is a property obtained from the base class. Okay, this property produces the application context instance. We can actually control the type of that instance. For example, let me show you. I will not be able to finish up, but yeah, I think this will be, for starters, enough to guide you through this. So I'm saying that here, regardless of our demo, I can actually have the demos host application, which is an application, like so, which is an application. I misspelled it. Usually my fat fingers, look, refactor, rename, my fat fingers, application, demos host application, like this, yeah. And now I do actually can have here the joke service for now by using a fake joke service, right? Cool, nice. And now, if I can access the instance of this demo host application, which is the application context, then I can reach the fake joke of this service. Why am I using this approach? Well, because for testing purposes, I can change which host application is being used. And here, now I'm using fake, and later on, I will be using a real implementation. So this will be kept like so. This one will have what I need for the actual production code. For now, I only have a fake implementation, and that version, the testing version, will have a fake version of the service implementation. So I can run my automated tests on it, okay, using it. And so this means that it's possible for me to, here, when I reach for the application, let me just log it, log.v. I'm pressed by time, I'm aware of it, sorry about that. Let me joke of the activity on create, and application. I will use a breakpoint, it's easier, okay? Val, my breakpoint, yeah, here. Breakpoint. It will be easier. And now, and faster, for sure. And now I finally need to state that I don't want a regular application to be instantiated. I want to use this type. And this is said on the manifest, like this. I'm going to say that, look, Android name, application name is demo host application. So this means that instead of using the default implementation, a demos host application instance will be used instead, like this. Okay, let's look at it, and I will finish up. Okay, let's breakpoint, run it. I need a button to launch. I need to add a button very fast. So I will go to the menu screen, main screen. This will have a button on navigate, title screen, navigation intent, navigate to user task, and here navigate to joke of day. Okay, now I will have a const val joke of day button tag, joke of day button tag, joke button. Como é que é, Skyward? Joke of the off button, really fast and pressed by time. Cool. Now another button. Great. Let me add this button. Navigate to joke of day. Joke of day. Not this. Let's go here and string name. Main navigate joke. Cool. Now translatable. False. And now I will use joke demo. Cool. It's done. Finally, joke of this service. Finally, I think, it's done, right? I think. Let's have here, let's handle it. Main activity here. Okay, there's one missing, which is title, intent, navigation. Okay, joke of the activity doesn't have. It does. It's done. Finally, let's do this. I think it's done. Okay, cool. And we will end it, okay? I will pick up in here, okay, later on, and show you how I pass on this dependency to the view model, okay? So user task demo crowdtail. This is why automated tests are required. Navigate to you, joke of the day. I do actually have tests for that too. Factory, it's done. Let's close it so I don't get confused with too many things open in a small amount of space. It's also done. Joke demo, joke of day navigate, button screen, main navigate, user task. This is the issue here. Okay. Main, navigate joke, joke of the button, navigate to joke of the day, and it's okay. So yeah, only the text was wrong. Cool. Joke demo. It broke. It exploded. Why is that? Because I was not running it in like this. It's not declared on the manifest. Of course, I forgot to declare the activity on the manifest. Here you go. Android, not this one. And this one, user task, joke of day activity. Here you go. What's wrong with you? Joke, joke of the activity. It's just confused. Let's go. Sorry guys, I'm on time. Yeah, sorry about that. I was just aiming to show you this, okay? Application. Okay? Here you go. Result is of type demos host application. You see here? Meaning that through application property of the activity, I have access to an instance of type demos host application, which has there the joke service, which we can use, therefore, to satisfy the required dependency. How does this help us? Well, I will show you next lecture, next Monday, that like this, we can, when running the tests, changing the application that it's used. And therefore, we can control which instance of which type of joke service is actually provided to our components. Okay? So sorry about being on time. I hope you guys have a nice one. I see you in the next class, either Thursday or Friday. So we can continue to work on your course project. Okay? Have a nice one. See you guys later on. Bye bye.